Hello everyone, and welcome back to the last of the podcasts in conversation with our gold medalists. I'm absolutely delighted to be here this evening with Jiemin Ding, who I've known for quite a few years on the board of the Institution of Structural Engineers, as well as my reputation before that as one of our gold medalists. And we met at the end of last year, and I was absolutely delighted when he agreed to be the last of our gold medalists in this series. And I think for me, what I'm really excited to hear about is his background into where his creativity and ingenuity and kind of technical strength came from, but particularly because I think it brings a diversity and reflects just the strengths of structural engineering that we have through our members all over the world. So with that, I'd like to say hello and a really big thank you. It's lovely to be having this conversation with you, and thank you for creating the time and being generous with your insights. So I'd like to start just by recognizing Jiemin Ding's work. And so I'll start with his bio. Jiemin Ding is a renowned National Master of Engineering Survey and Design. He currently serves as Chief Engineer of Tongji Architectural Design Group and is a doctoral supervisor in structural engineering at Tongji University. He also holds prestigious positions as Global Vice President of the Institution of Structural Engineers and chairs the editorial board of the Journal of Building Structures. Professor Ding has dedicated his career to the research and design of structural engineering, and I'm really looking forward to hearing about both through this conversation. He has been a long-standing judge of the Structural Awards for the Institution of Structural Engineers, as well as various major domestic structural awards. His exceptional contributions to the field have earned him numerous accolades, including the 2017 Lifetime Honorary Membership by the Structural Engineers World Congress, the 2018 Gold Medal by the Institution of Structural Engineers, and the 2019 CTBUH Fellow of the Council of Tall Buildings and Urban Habitat. Throughout his career, Professor Ding has led numerous research projects, receiving multiple Science and Technology Progress Awards, including 2 second prizes in the National Award for Science and Technology Progress. His design work has garnered nearly 100 awards, including a National Silver Award in Design and numerous industry first prizes. In addition, he has published 5 monographs and over 200 academic papers in both domestic and international journals. It's incredibly impressive, Professor Ding, and thank you for joining us.
Yeah, thank you. Thank you very much, Tanya. Thank you very much. And thank you introduction for us. Really, I'm very glad to take part in iStructure work and also help us to renew as a structural engineer. Thank you. Thank you very much.
Thank you. And I love that. I love that we share that passion for both our profession, but also the future of our profession and inspiring people. And with that, I'm really interested in the engineer behind the engineering. And what I mean by that is the person behind the actual projects and the buildings, and how we can see the inspiration and the background of those people manifest in our buildings. So I'd like to start, and I'm really excited to hear a little bit about your background and some of your projects, but also, some of the things that have allowed you to be inspired and also, I guess, be influenced in terms of how you've brought that into your engineering.
Thank you, Tanya, to introduce myself, my career. Now, I will introduce my very briefly. First, about me. For me, education background is very simple. I'm from the 1979 to the 1990, I get the bachelor degree, master degree, and the doctor degree from the Tongji University. Work experience is also relatively simple. From the 1990 to the present, I worked at the Tongji Architecture Design Institute as the vice president and the chief structural engineer. And also, I got some personal honors. In 2017, I won the SEWC Lifetime Honorary Membership Award. This picture showed I get the award, I do a speech. And luckily, in 2018, I won the ASHRAE 2018 Golden Member. This is a picture. The president gave me the honor. And also, in 2019, I won the CTBUH 2019 Fellows. This is a picture, get a fellow, we take the picture together. Now I will introduce very briefly about the design and practice. In my career, I have designed more than 30 super high-rise buildings. For this figure shows some of the design practice of super high-rise building. And this figure this table shows the part of design practice of large span buildings. And also the table shows the parts of design practice of the complex buildings. Now I will introduce some buildings design. First, the practice in super high-rise building and large span build structure. This is a very famous building. Now it's the highest building in China, Shanghai Tower. We get a lot of the consultants together, work and design. Also, the building get a lot of award from abroad and in China. This picture shows the 2018 Best Tall Building Worldwide. We get the award. And also in 2018, I get the Outstanding Structure Award from the YABS. This is a picture showed we get 2019 Shanghai Science and Technology Progress Award and 2023 National Science and Technology Progress Award. This picture showed after building and during the building of the Shanghai Tower. This is another super high-rise building located in Xi'an City. The height is near the 500 meters. We worked with SOM together. This is a very simple introduced structure system used for the super high-rise buildings. This PPT showed integrated design of the architecture and structure, optimized of the elevation and plane profile. This optimization should be reduced wind load influence. This figure showed how to optimize to reduce the column numbers and make the structure design more easy and more beautiful. This is another optimization with the architecture and the structure. We also do the table tester in the Beijing. This is the picture showed the model of the table taster. This big picture showed the building during the construction. This is a very interesting large span buildings located in Shanghai in 2009. This is a roof shape. This is a structural system used for these buildings. At that time, this building is the largest span in the Shanghai. This is a picture showing the interior of the building. Another building located in Xi'an City. This is a Silk Road International Conference Center. This picture very briefly showed the roof plane in building, in architecture and structure. And this showed some seismic isolation technology used for these buildings. This picture showed the isolation located in this building in the basement. After construction, this picture showed the building looks very nice and beautiful. This is the elevation of the buildings. And then we can see the integration of the architecture and structural design. This is a building located in Shanghai, means diving pool of the Shanghai Oriental Sports Center. We worked with the GMP of German architects. This building get a lot of the honor and also looks very beautiful. And this is structure system show and used for these buildings. After construction, we can see that the building looks very clear, very simple, and very comfortable for the architecture. And this is another picture which looks very nice. This is also a sports building located in Shanghai. This is a swimming pool. It's also get a lot of award in China. This is a structure used for these buildings. The wood material used for this building. This some details showed the roof structure. This some detail about the joint. After construction, we get some interior view of the buildings. And this is another sports building for the bicycle. And we can see that the building looks very nice. And this is a structure model, 3D printed structure model, and is very comprehensive with the architecture. This building showed the structure construction. This roof picture show after construction, and it's also some detail. This is elevation of the architecture. Now we can introduce a Tibetan Art Museum. That project just get the structure award last year. This PPT shows some structure design features and some new technology used for this for this practice. This photo showed the before transformation. This factory built in 1930s, 60s. This big picture showed the after transformation. Looks very clear, very clean, very beautiful. This is a photo showed interior view of these buildings. For two pictures show the before and after transformation. And the mild steel damper is used for this reconstruction. This is a morning picture, show the whole view of the practice project. Now we see some pedestrian bridge. This is a bridge located in Hangzhou city, very near in Shanghai. This PPT showed the model of this bridge. The span is more than 100 meters. This bridge designed with the Zaha Hadid office. This is a bird view of the bridge. Looks very clear, clean, and nice. This is elevated view of the bridge. And we see this projector located in Tianjin city, north of China. This is some structural system used for this projector. We mainly focus on the roof structure design. They should be coordinated with the architecture view and the interior view. This picture shows the after construction, the roof interior is very clean, very beautiful. This is a different view of this projector. And third part, I will introduce application of new technology. This is very famous Shanghai Symposium Hall, designed in 2008, completed in 2012. This get a lot of award in China. This optimization of from the structure design, we can see the original scheme in middle process, and final scheme. This interior view showed after construction. And this interior view from different view. This is also looks very nice. That is a very simple introduction for myself. Thank you.
Thanks, Professor Ding, for that intro into your background and your projects. I'm really interested in general in an engineer's personal connection to projects. And so I wonder, the projects that you've shared with us are incredibly inspiring from a structural engineering perspective. And for me, they demonstrate beauty, creativity in engineering, but also confidence in the practice of engineering, as well as the breadth and depth of engineering application that I think for many of us is enviable. I wonder, is there a project or projects that hold special significance for you? One that perhaps challenged you personally or made you reflect on the important work and responsibilities we have as structural engineers?
Ms. Tanya, that is good and difficult to answer the questions. To become a qualified structural engineer, in my opinion, the following are essential. First, participation in the design of the major engineering projects that allow you to apply the structures engineering knowledge comprehensively. For example, Shanghai Tower, the height is more than 600 meters, designed in 2008. The project get a lot of awards from China to award worldwide. That is also very comprehensive and difficult project. We should insist to design and to cooperate with the construction. This picture shows that during the construction and after construction, the building looks very nice. But during the design, a lot of things not so look like very nice. This is another project located in Xi'an City, the International Conference Center. Two sides of this building is more than 200 meters. That means that is a huge building. We can see the elevation from the different view. That is very nice and beautiful, very like the conference center. From this, we can see the second should creating structure that can appropriately express architecture, aesthetics, and culture characteristics. That means the structure design should be let the architect satisfied. You can see the diving pool of the Shanghai Oriental Sports Center, designed by GMP Architecture Office. This project get some award from the worldwide. This view shows that the elevation of the building looks very nice. So we also should be insist to let the structure system choice meet the architect's requirement. And another sports center is also located in Shanghai. This is for the bicycle. This is another elevation, looks very nice and beautiful, and also show the location culture. That is another super high building located in Xi'an City near the 500 meters. This project designed with the SOM office. This picture shows the building during the construction. The height is near the 300 meters. From this point, we can get 3 points. Mastering advancing structural engineering technology tools and apply them in engineering design practice. This is Shanghai Symposium Hall. And from this PPT, we can see the optimization of the roof structure from the 2D structure system change to the space structure system. We can see original scheme in process, and final scheme. And this is another project located in Shanghai. This is Opera House. The opera house is located very near the subway, just about 10 meters. So the building is also extremely high requirement in acoustics. So the isolation structure technology used for this building for separate the noise caused by the subway.
Wonderful. To me, your work often appears to successfully balance beautiful forms with structural rigor, which of course is essential, but it's not always that easy. How do you personally define the role between engineering, art, and architecture? Do you find that your work or your understanding of engineering has been influenced by areas outside the field of engineering, such as art, perhaps nature, philosophy, that might influence or inspire your creative process? Or have you found it more to be about pure engineering itself? Just love to learn a little bit more about who you are and what inspires you and how you bring that into your engineering practice and into the buildings that you've been responsible for designing.
That is a very interesting question. For my opinion, the relationship between the aesthetics and the mechanics in the East can be expressed through yin and yang, a traditional pattern. In this pattern, only with two color, white color and black color. But they let architecture with the structure together, but they are also independent. So in this pattern, the two are independent yet play different roles. I think pedestrian bridge design can easily to show the relationship between the architecture with the structure. Now I take some examples about the pedestrian bridge design. First is the bridge design located in Shenzhen City. The span is more than 170 feet. This is a structure layout to show that the land, the site situation, and the mainly structure size. And for this force distribution, we can see the consensus with the internal force distribution along the beam, along the bridge. We use a different color show the compression and tension. The red one means compression side, the blue one means the tension side. So according to the internal force distribution along the beam, we can change the section of the beam to make in a different height of the section and to form a very reasonable structure system. For this bridge, just under the construction, so we can see after construction, the pedestrian bridge should be look very nice and coordinated with. And then we can see another bridge located in Hangzhou City. The length is about 377 meters. This architecture designed by the Zaha Hadid, the structure designed by Tongji University. For this is a very brief, simple structure system show the figures. For floating, single side suspending, and space-shaped tied arch bridge. Also have some structural characteristics. The architecture design make the arch pier present a space continuous, bent, and twist form. We can see some structure member section and cable arrangement and others. After construction, we can see that the bridge is very beautiful and have some romantics. Finally, I will introduce another bridge across the river in the Shaoxing International Convention Center. The span is about 120 meters. Architecture and structure design also by us. Truss cable hybrid structure system used for this bridge. That looks very simple and beautiful. After construction, we can see the bridge is very beautiful and looks very nice, especially in the night view.
Personally, I'm really interested in the human aspects of the engineer and of engineering. And as part of that, I'm really interested in the role of intuition in engineering. How important do you think intuition and critical thinking skills are today in our practice, where we're seeing a lot more digital tools, excitement around artificial intelligence and other digital tools to speed up our work are a lot more common versus decades ago? Do you think that intuition plays a stronger part? Or do you think that that is something that can be replaced by some of the new tools that we're looking to the future of engineering to help us deliver structural engineering practice in a really different way?
I think structural engineer should have a profound and systematically understanding of various material behavior and various structure system how to use. On this base, the intuition developed from the engineering experience can greatly help us to improve the design quality. Secondly, the structural computer analysis can help us to verify the correctness of the structure design result. But it cannot fully replace the human thinking and analysis. Of course, as artificial intelligence processes, some routine work in structure design should be replaced by the artificial tools. For example, Silk Bridge located in Hangzhou City, the span is about 108 meters. The wide is normally 7 meters. For the pedestrian bridge, the width normally is from the 4 to 6 meters. That is 7 meters. At first, we showed the scheme 1 as a structure system for this bridge. And after structure analysis and consider some experience, we get scheme 2. Finally, we get scheme 3, the structure system used for this bridge. And we also can see the structure layout like this picture. We show the 3 model for this bridge. And for the picture, we can see after construction that the bridge looks very nice and suitable for this. The structure system is suitable for this bridge. Another example located in Changsha, Hunan province of China. The architects required a roof shaped like this. That is not benefit for large span structure. And according to the normal structure system and the behavior of the structure under the vertical and lateral load, according to the structure analysis result, finally we chose the very special structure system used for this bridge, for these buildings, and can satisfy the the requirement of the architecture mind, and also the interior space also can satisfy the use of the buildings.
So I don't think we could have a conversation at the moment without addressing sustainability and the impact of climate change on the built environment. So with climate change impacting the built environment globally, and particularly environmental sustainability becoming a major consideration in structural engineering in many parts of the world, especially delving into embodied carbon and reducing that, what changes are you seeing in the way it impacts your work and your region? Do you think that it has a potential to increase innovation and creativity in structural engineering, or is it really hindering it as we're looking to reduce embodied carbon and negative impacts on the environment through our work?
I think climate change is a shaky thing. We cannot stop it, but we can delay. More than ever, we are focused on eco-friendly design and sustainable material. That means, as possible, as possible, we use the structural material can be green and recycled. As structural engineers, we are designing the building or bridge that not only satisfy the safety, but also can be satisfy the sustainability. For example, this is a swimming pool building located in Shanghai. During the design, we compared the different material. Finally, we used wood and steel material made to form the roof structure. This picture shows the use of the different material on this projectile. This shows the structure feature, the timber structure combined with steel. Middle span bending moment is a small and adopted wood structure, and the span bending moment is large and adopted steel structure. Closed tables are used to improve the stability and read under the to improve the stability. I just showed some detail. After construction, this showed interior view. It's very good and can meet the use of the interior. Another building just finished last year is the Tibetan Art Museum, located in Lhasa of the Xizang. That project is very lucky. Get the last year Archie's Spring Award for structural engineering excellence. Before the transformation, the picture showed that very old, this is a cement factory built in 1960. This view picture showed that after transformation.
One of the reasons I was really excited to have this conversation, Professor Ding, is that you bring a unique perspective as a gold medalist because of your work in the East in comparison to many of our gold medalists from the West. And so I'm really interested in what insights we can learn because you can bring both perspectives to the practice of structural engineering. Many of your projects are internationally award-winning and recognized on a global scale. You've also been involved and celebrated extensively both in China and abroad, such as ICE Track D Gold Medalist and a CTBUH Fellow. So, through your involvement in both structural engineering in the East and West, what unique perspective or insight can you give us? For example, perhaps there are different or unique approaches to education, training, knowledge, or experience that some of our audience might find interesting or perhaps inspiring.
For my opinion, the basic principles of the structural design are consistent between the East and the West. That means it's almost the same. The figure on the right shows the three levels during the structural design. First, we should applicable. Second, we should be economical. And also, we should get the green level. For the structural design, usually should meet the three level. First, should coordinate with the structure architecture design. Second, the structure design should be readable and should be safe. Third, structure design should be economical and environmental friendly. However, the focus of the different development varies in the different stages and the regions. That means in different regions, when sometimes you should be focused on the green and aesthetics, sometimes you may move focus on the economy or applicable. We take some examples that is designed by us in the Chongqing railway station that also get some award. We chose the structure system is very simple and can match the architecture design. That is looks very usual, and as some is structure system is very reasonable. After construction, we can interior view that is very that the interior space can very satisfy the use of the architecture and combine the facade design of the architecture. The structure system use different system to compare, and finally, we chose the arch structure. The length is more than 100 feet. A second example is the gymnasium located in Shanghai, Fudan University. We considered the architectural requirement and chose a very suitable structure system. We combined the arch structure and also a roof structure. After construction, we can see the interior view is look very simple and can meet the various use requirements.
And finally, because I'm so passionate about the impact of engineering on society and the environment, I couldn't finish without asking you about your perspective on the possibilities for engineering both now and in the future. As a gold medalist and a leader, your career is an inspiration to many. What do you hope people understand about your journey as an engineer? And what message would you give to young engineers or perhaps those aspiring to become engineers or people that just want to make a difference in the world and not quite sure how to do that? What message would you give them about engineering and the potential positive impact that it has on the world?
I think this question is a good question and is difficult to answer the question. I'm sure the question have no uniform answers. For my opinion, the emergency and the evolution of the AI technology will bring profound change to the field of the structural engineering. But this change is gradually allow us to learn and to adapt it step by step. Everyone knows the building industry is one of the earliest industries that have been with human civilization yesterday and today. I'm sure it will be continue follow us to the future of the human civilization.
Professor Ding, is there any one thing you want to say, a piece of advice to younger people, or is there any last thing that you would like to leave people with?
I think for the young engineer, tomorrow will be better than today and also different from today. Something will be changed in structural engineer. Something will stand there smoothly. I'm sure AI intelligence will let structural engineer develop the more smoothly, more faster, and more better. We're sure tomorrow will be better than today.
I love that. Thank you. And it's a wonderful way to finish with that upbeat perspective that tomorrow will be better than today. I think that there can be a lot of focus sometimes on some of the big challenges ahead of us, particularly in terms of climate change and challenges at attracting people into the profession. And so it's really nice to finish on that positive note, thinking about the profession and it being better tomorrow than it is today. Well, thank you, James. This has been a wonderful conversation, and I think really special because I don't think many people would have had such insight into your work. And I love the fact that it makes structural engineering all over the world accessible and really inspirational to a larger group of people. So really appreciating you making the time and sharing a lot of your career with us. And I hope for many more conversations to come.
Thank you, Tanya. Today's conversation is very beneficial for us, especially for me. And let us think about the structural engineer things and also review some projects we ever designed. And I think we slow the conversation today. We learned a lot. And thank you all. Thank you.
Thank you. And I certainly have learned a lot, and I'm sure, particularly for younger people in the audience, as well as people that have followed your career, they've also taken away something unique from this conversation. So thank you.